Hello, in this video I will prove a formula of a histogram-based approach to enhance the contrast of images. First of all, let's see what an image with a bad contrast looks like. So here I have two images. This is the first image and this is the second image. And these two plots are the respective histograms, or also the PDF, the probability density function, which is almost the same as the histogram. So what the remark about these two images is that the histogram of the image with the best contrast is spread out over all the possible values of gray levels, whereas in an image with a bad contrast, the pixels tend to be clustered on a specific range. For example, in this situation, the pixels are clustered almost between the value of 90 and 175. So from this experiment, and also from a lot of other experiments and PDFs of a lot of other images, we can say that an image has a good contrast if its PDF, or the probability density function, is as uniform as possible, which means that its PDF should be continuous. So this is the idea of the formula I'm going to prove, which is called global histogram equalization. We have an image with a bad contrast, and this is what its histograms will look like, or the probability density function. So the values extends from 0 to 255. So for the sake of this study, we will assume that the probability density function is continuous, which is not the case for images, because images are digital and the values are discrete. So just for the sake of this proof, consider that the PDF is continuous. So for an image with a bad contrast, we might get a probability density function that looks like this. And our goal is to make it as continuous as possible. So we want to transform its probability density function such that the PDF is continuous. This is the PDF of the new image, or of the enhanced image. So X here represents the pixels of the image with a bad contrast, and here Y represents the pixels of the image with the good contrast, or of the enhanced contrast. So here we have 255, which is the maximum value for an 8-bit image. And here the amplitude of this probability density function should be 1 divided by 255. This is because the area of the probability density function should be 1. the probability cannot be higher than 1 or 100%. This is why the amplitude here is 1 divided by 255. Now, what we want to do is to find a relation between f of x and g of y. We want to find a mathematical relation, and once we do that, we will find a relation between y and x. A relation between y and x. This is actually what we are looking for. So in order to find this relation, we look for the relation between f of x and g of y, such that f of x is the PDF of the first image, the original image, that contrast image, and g of y is the PDF of the enhanced image. That's it. So we want to find a mapping function of the values of the original image, which are denoted x, and this function will map the values of x to a new value that we shall call y. This is what we want to find, this transform actually. And this transform shall be denoted y of x.